We saw the last time that corn and bash, that's the born again shell, both use $home shell variable. Also they both have the noclobber option. The noclobber option, once again, it prevents you from overwriting an existing file. And we saw that once we turn on the set -o noclobber and we try to clobber a file, we get a message saying you cannot overwrite existing file, but we can override that by using this greater than pipe operator. So what this is one operator that says, okay, we might clobber that file, but I want to, in case we have no clobbers set as we do now, we still want to override that noclobber and write to it. So this time around it works. So once again, ordinarily when you say pipe the output of a command to a file, if it's not there you create it, you can clobber it by default. That's the default behavior. You can use set -o noclobber to not have that default behavior and have the default behavior be noclobber, so that if you try to clobber it you get an error message, and then on top of that you can override the noclobber. Alright, so you might want to try that to get used to these different options. Command line editing is a way to execute commands that you've executed in the past. So it turns out there's a command called history, which we'll get into soon, which tells you all of the commands that you've executed in the past. And one way to go through that list is to use the arrow key right at the command prompt. So I'm going through the arrow key. I'm using the up arrow, and what you'll see is I'm just going through this list of all the commands that I've executed in the past. I can go up and I can use the down arrow, and what I can do is I can actually change. So I'm using the left arrow key to actually change a command, and then I can rerun it. Okay, so since I have no clobber set, I cannot overwrite it, but I can use the arrow key again and clobber the file. This time it works. So in addition to this, the corn shell allows VI editing of commands. So we're not going to discuss this here, but it's discussed in detail in the book. And if you want to try the corn shell, what it allows you to do is re-edit old commands, but you can use VI to edit the command. But I want to move on and look at another thing that's common to both the corn shell and bash, that is the born again shell, that is the alias command. We've seen this, we saw this in our profile settings. And you can, by itself, this alias command will show a list of all the alias that you currently have, and we saw that before. Let's take another look. Just type alias and you see a list of all the things that are aliased. You can create a brand new alias if you want by saying alias, and this time you put in space, and PWL is going to be our alias for a new command. Oops, let's use single quotes to protect everything. You can say pwd semicolon ls -l. Okay, and by default doesn't get run until you actually type in the command pwdl. That's our new command. Oops, we forgot. There. And I've fixed our command with the new alias, and sure enough it works. There's our pwd output, and here's the output of ls -l. So if you execute these two commands together all the time, you might want to consider making an alias. Okay. So we looked at the history command. What it really does is give us a list of all the commands we've executed in the past, numbered. Another way to get this is to use the fc command, which is discussed in detail in the book, and something that we don't really use a whole lot in our labs, but it's there. So if you say fc minus l. Basically see the same thing that we saw before. Okay, so fc is a much more powerful command, and usually we use it just in the minus l option, using it the same way as the history command. And we won't go over this in a lot of detail, but fc has a number of options. You can use -n to suppress command numbers. So -l n just gives us the same thing without the command numbers. You can reverse the order, have the most recent at the top, and you can use -s to re-execute commands without invoking an editor. A few more things that are common to both Korn shell and the born again shell, as discussed in the book. As far as login and startup, you can add commands to the .profile file and the .bashrc. Those are customized just for you. That's you, the user, not for the whole system. And you can, for example, print out the date and calendar right at the beginning. So as soon as you log in, you can have a calendar view of the current month or the current year if you really want to, and the current time and date. You can add event numbers to the prompt, and you can do this at any time, but it's most often people do it in the startup files. So here's a simple example. You say ps1 is equal to exclamation. So ps1 is equal to, and we've done this kind of thing before in the previous videos. So the backspace character, or sorry, backslash is used to protect the exclamation operator, which is usually interpreted as, I believe, as the not operator, like in Java. As soon as you do this, you will see that every time you enter a command, you will get a new number, and this will correspond to the history. So if I say history, you will see those same numbers. This is a good way to execute all commands by number. So you could do exclamation 349, and that should re-execute the alias command. Or I can say exclamation alias. I believe you can also say exclamation A. Does the same thing. So you can be as simple as exclamation A. This will search for the last command that started with an A, and it's, in this case, it's the alias, and so it'll execute that command. It's very nice if you just don't want to type a lot of commands. You can execute anything from your previous history using the exclamation character, or in Unix it's called the bang character. So to format the prompt variable, we also saw how to display the time and the current working directory. That's \uppercase W. This is a list from the book. The uppercase W is not in the list, but a whole bunch of other things are. The bang character, $D for date. That's not terribly useful. Time is usually a lot more useful, but you can combine them. And the last thing I want to take a look at very briefly, because this is something that we'll get into a lot more detail when we write C programs. We will use these things like fork and wait, exec and exit. All of these things will be used from C programs. The main idea is that these are all things to manage processes. When you call fork from a program, what you do is you create a brand new process that is a complete copy of everything that you have in here, and you start from the point. It's just like so this is called the parent and this is called the child, and whenever you call fork, you start from exactly where you left off in the parent and execute everything else in the parent, and you do that in the child as well. So once again, when you call fork, you create a new process, you add the child to the process table and store the parent return address in the process table. You send two codes, you send different codes to the parent versus child. So remember that every time you call a function, this is just like a method in Java, if you're going to return something, you return either an int or string or whatever. In this case, you're returning an int. The parent sees one int value, the child sees a different int value. The parent sees the process ID, the child process ID, whereas the child sees a 0. So this is an example of a function that returns in two places with two different values. The child ID gets returned to the parent, 0 gets returned to the child. Okay. So let's say after you fork, you call wait. What wait does is it gives control to the child process, and the parent goes to sleep until the child is done executing. And that when the child is done, you go back to wait and go on with the rest of the functions that you call in your program, in your parent program. Once again, let me just emphasize that this will all be much more important when we write C programs. So we will go over this again once we get to C programs, and you will do all of this in C. Exec is something that's very similar to fork, but it's different. What exec does is it does not actually create a new parent. New process. When you call exec, so let's say the child calls exec, and it's usually what happens in a shell. When you call exec, you remove everything else, and so no other code beyond exec is executed. All of the code for this, since let's say it's a child that calls exec, all of that is replaced by whatever file that you choose. So this is a way for one process to start up another completely different program. In the case of fork, what we did was the parent ran a copy of itself, but with exec, what happens is exec replaces the current program with some other program, but keeps the same process ID. So a big difference there's many differences between fork and exec, but one is that with fork you create a brand new process with a new process ID. With exec, you do not have a new process ID. You keep your old process ID, you have a brand new program. Alright, and lastly, exit, we won't deal with a whole lot right now. Exit just changes the status of this. For example, in this child, if you're waiting the child, if the child calls exit, it changes the status of the parent to active, removes the child from the status table, and there's a whole bunch of things that basically awakens the parent and says, okay, this child process is done, so now you can continue your program. That's if the parent was running wait, and that's typically how it's used. So this is an outline for how the bash shell works. The bash shell is a parent. Every time you type in a command, you actually start up a new process that's a copy of the shell itself, but then you load, using exec, you load in whatever command that you wanted to execute. So if the bash shell is running and you type in ls, bash shell forks, and then it just waits. In the child, what you do is you exec the ls command, so it replaces the bash shell with the ls file, and eventually when it's done it calls exit and it returns. The bash shell is waiting, and when this ls command effectively executes, the bash shell restarts, and what it does is go back around and print another prompt and wait for the user to type in another command. So this is a look at the details of how bash works.